Hello, my name is Peter Krushka. I am a student at Kennesaw State University, and this is a brief discussion on the two of the operating systems and firewalls that we're using in our ISA 4220 class hosted by Professor Green. Now, basically, an operating system overview. The key issue here is the kernel. The kernel is the main executive inside the operating system. It controls the CPU or thread processing inside the CPU. It controls memory management. It controls the allocation of memory such that what applications can use what memory spaces. And also paging, sometimes moving blocks of memory from RAM onto the hard disk surface. These are all things that are done by the memory management component of the kernel. Devices also are accessed via the kernel, and applications too. Applications, when they run, if they need any CPU services, they basically have to request an interrupt. The operating system will acknowledge that interrupt and then provide the services that the application needs. Now, in our course, we have two vendors. We have two product operating systems we're using. We're using Windows Server 2012, and we're using the Ubuntu 16.04 long-term support. Windows Server is manufactured by Microsoft, and it has gone through a number of iterations, starting even before 2003. But for the sake of this discussion, we're starting with 2003, which is no longer being supported by Microsoft. And then after that, the next release was Windows Server 2008. I believe there's also a 2008 R2 version. And now we're up to Windows Server 2012. And we have to pay attention. When you're working with operating systems, you have to sort of pay attention to the product line because these products do evolve. And there are new features that come out. For example, in Windows Server 2008, when it was released, had a new product called Hyper-V. That didn't exist in 2003. Hyper-V is a virtualization tool that allows Windows Server to support multiple virtual servers within its own environment, much like we have VMware. Now, Ubuntu is developed by a company called Canonical Limited. I believe they're out of Australia. And Ubuntu is a Linux flavor of operating system. And we are using Ubuntu 16.04 LTS. Now, what I'm going to do for this presentation is I'm basically going to discuss the boot process in a Windows environment and then also in a Ubuntu environment. So I'm starting with the Windows. Now, I'm just going to kind of give a high-level overview of this. I'm not going to go too deep on this. But in sequence, basically what happens when a Windows server boots up, first the post is performed, which is a power-up self-test, which is a basic rudimentary diagnostics of the system board. Next, we go on to the BIOS, which is basic input-output system, which is enough of control so that we can find the software that will start the system. And I'll discuss that a little more deeply in a moment. And here's something new that I discovered in this presentation. We have Unified Extensible Firmware Interface, or UEFI. And apparently that's replacing BIOSes that are out in the field. And this UEFI is it's a new way to interface the firmware on the system board with the operating system. So once we start going on, we progress to the MBR, the Master Boot Record, which is typically on the hard disk drive 0 at sector 0. That's pretty much standard. Once the Master Boot Record is loaded, from there the boot configuration data is loaded onto the CPU, and then the boot manager takes over. The boot manager then starts the system. It runs WinLoad and WinLoad exe, and that file, by the way, is managed with a utility called bcdedit.exe. So WinLoad loads some drivers and the NT operating system kernel. This is where it really starts. Now, some of these next items, WinResume, that just recovers the system from hibernation. But the NTOS kernel is the executive core of the operating system. Next comes the hardware abstraction layer dynamic link library. This loads enough of the chipset functions so that the operating system, then later on the drivers can actually interface with the operating system through the hardware of the system board to the various devices that are been installed with the system. And some of these next applications will support user session, thread management, authentication, local security. And I want to spend just a moment talking about this next one, this system registry. I've abbreviated SYS for system. Now here you have keys, subkeys, and values. This is going to be a database of the entire system. It's a very critical database, and corruption here could invalidate the operation of the system. So care must be taken if anyone's ever going to edit the system registry. And then finally you have the drivers. So we printed drivers and any specialized software, that scanners that may have been installed. Now some of the vulnerabilities that may be encountered are in the BIOS and the UEFI. They can be compromised. BIOSes do have passwords, and in my experience, some they're not always set. And these units should be write protected. And that could be difficult if your organization has a large number of workstations. But the basic rule over here is apply updates when possible. It should be a little bit easier with UEFI because if I understood my research, they can be remotely activated, but they still should be protected. Many of the Windows vulnerabilities are related to privilege elevations, and the best security for that is to apply patches when they come out. Now in the Ubuntu process, it's somewhat similar, but it also appears to be a lot simpler. You still have a BIOS UEFI, and then we get to a bootloader, and the bootloader in our particular environment is Grub. And Grub is what's actually going to go out, find the kernel, which is the executive program. The kernel loads, and then you have the initram file system, which is a utility that loads enough of a file system for the kernel to continue its operation. Linux systems have this characteristic that a file system can't be used until it's mounted. So this udev daemon is going to mount the file system, mount the root file system so that the operating system or the kernel can continue to load. And with the Ubuntu environment, you have this upstart, which starts tasks and services. And it does that by referencing all the configuration files that are in the etc/init directory. My experience when a Linux box boots, or in this case also the Ubuntu, pay attention to the startup screen. You should see a lot of text going by very quickly, but the newest systems will have a Go printed in green as the particular service starts up. If a Unix system or a Linux system boots properly, they will all be green, and they should all be green. If not, it could be a cause for investigation. Boot vulnerabilities with the Ubuntu system. Somewhat similar to the Windows system. The BIOS can be corrupted, and also the UEFI. Notice there are some security vulnerability discussions about these items. And Grub itself is vulnerable to authentication bypass. So the issue here, or the recommendation here, is make sure that updates are always installed. And when working with Linux or Ubuntu, some of the best practices that should always be employed are use least privilege. Never log in with root just to do a routine task. Log in with your generic user account, and if necessary, then do switch to super user to do any necessary privileged activity. And never ever surf the web from a root login. Now, firewalls. I'm not going to go too deep into a discussion here. This is a topic that requires its own presentation. The firewalls basically monitor and control traffic via rules, and they can either allow or deny internet connections, and that would be based on source and destination IP addresses, based on the protocols that are actually being used, and based on port assignments. Here's a comparison between the Windows and the Ubuntu firewalls. In Windows, it's typically accessed through the Start menu, Start Control Panel, Administrative Tools, and Firewalls. And then I also have the command line, so that would be wf.msc, and that should then get you the GUI for the firewall, which I've got a picture of it here. Now, Ubuntu, their firewall is called Uncomplicated Firewall. Now, basically, on Linux systems, firewalls rules are managed via IP tables. Well, Uncomplicated Firewall makes that a little bit more manageable. And for a complete instruction on how to use the Uncomplicated Firewall, you would refer to the Ubuntu 12.04 LTS UFW manual, and that should have a listing of the commands for you. Actually, it will have it, and with instructions on how to use them. Now, firewall vulnerabilities. I had to think about calling firewall vulnerables because, yeah, they're susceptible to denial of service attacks, which last time I researched that, they're almost impossible to stop or do anything about. So the only solution would be to have pay your service provider for an alternate network path, which means having redundant backups. But some of the major issues with firewalls are basically administrative, poor administration. Either rules are not configured, unused ports are left open, administrators either don't keep and or analyze logs, and sometimes deep packet inspection may not be activated or installed. These are all things that could enhance the security of the data behind the firewalls. And I believe that's it. These are the references that I've used in the preparation of this presentation, and I hope it was all helpful to you. Thank you very much for your attention.